Hello guys, welcome back to the channel. Like we always do, we are going to solve past papers, all right, to really understand the concept binomial theorem. Right? Okay, it's part of the topic series. We have already covered the aspects of arithmetic progression and then geometric progression. So all that you have to do is to watch that video. You haven't watched it already, but this one is certainly going to be on binomial theorem. So the worksheet is in the description. You can download it and work alongside with me. All right, but if you haven't subscribed already, I believe now is the time to subscribe. Because why? I'm going to always give you quality videos. So let's start with the first question. It says that using the binomial theorem, expand this, okay, and then simplify each term. Right. Now, note that the binomial theorem would always be given in exam room, okay, to be part of the formula sheet. So if you don't, remember, don't panic, all right? In fact, let me show you something right now. Let me show you something right now here. If you go to Add Maths, let's say 2021, any of the major papers, you will see that it has the binomial theorem right here. Okay, so this is the formula that you'll be given. You don't have to memorize it. Okay, that's the point I'm trying to make. Don't memorize it one bit. All right, so now let's solve this particular question. Right, but I like to write the same formula this way, like let's say a plus b to the power n. I like to go with this a to the power n plus then n combination 1. A will reduce by 1, and then b, and then I have n combination 2. A will reduce by 2, and then b gains 2. So this is how I like to write it because it makes sense to me this way. All right, but you can also write this exactly how Cambridge will put it, like this way, and then you go with it. But if you see that n1, what they are saying is that use this formula. It's a combination. So just if you see n1, it basically means n combination 1. Okay, so don't panic, is the same thing. All right, now let's start with this particular question and solve it. So we have something like this, to the power 4. So that means we are going to expand everything. So we have 1 to the power 4 plus then 4 combination 1. All right, 1 to the power 3, and then we have e to the power 2x. Then the next one, we have 4 combination 2, 1 to the power 2, okay, and then we have e to the power 2x all to the power 2. Then we have 4 combination 3, we have 1 to the power 1, and then we have e to the power 2x all to the power 3. Then finally we have 4 combination 4, 1 to the power 0, of course, and then e to the power 2x all to the power 4. All right, okay, so now that we are done with that, we just have to work with it. So 4 combination 1 is definitely 4. 1 to the power 3 is still 1, so this is 4 e to the power 2x plus, then we do 4 combination 2, that is 6. So we have 6 e to the power 4x. Why? Because think about it, this times that is definitely going to give us the 4x. Then the next one, we have 4 combination 3, which is 4. All right, so we have 4. Now be careful here because 3 times 2x is going to give you 6x, so e to the power 6x. Then the next one, 4 combination 4 is definitely 1, right? So you are just left with e to the power 8x, all right, and then you are done. So you have fully expanded that question, and then you are good to go. Actually, this question came in the year 2021 May June paper 2-2. All right, let's try our next question. This is also February March paper 2-2 2021. So let's give it a try. It says that in the expansion 2k x over k all to the power 5, we should find a value of what? K, right? if the coefficient of the s squared term is 160. So we are interested in the s squared term, right? So let's expand it. First, we have 2 to the power 5, okay? 2k to the power 5. After this, I'll show you the shortcut. I want to just expand the whole thing and then use the shortcut to help you out. All right. Okay. So then plus we have 5 combination 1, 2k to the power 4. Then we have negative x over k. Then we have plus 5 combination 2. Then we have 2k to the power 3. And then we have negative x over 4 square. Now pause here, because when you expand this term, it's going to have the s square, and we are interested in the s square. That means that really we are interested in only this. Okay, now what is the shortcut I'm talking about? Well, since they are talking about s square, okay, so this is what you can do in your shortcut. If you have k 2k minus x over 5 all to the power 5, sorry, it's over k. Okay, they want the s square, right? Now the s square would mean that you are dealing with 5 combination 2. Why? Because if you look at the combination, how this thing is working, if you have 5 combination 1, the second term has a power of 1. 5 combination 2, the second term has a power of 2. Even let me add one more to 5 combination 3, even though it's not needed. I'm using it to prove a case here. So you will have this 2, and then the second term is going to take a power of 3. So whatever that you write down here is the power of the second term. So if I want s square, then it means that I want the second term to have a power of 2. That means that I should just do 5 combination 2 and I'm good to go. So you just maintain the first term. Maybe you don't know that, so you just keep it blank and then write the second term as x over k, right, to the power 2. Now the question is, this second term, the first term here, what power should it have? Well, up to this 2 that you have here, if you subtract it from 5, what is the answer? It's 3. So that's the power it should have, because at the end of the day, if you add this to that, it should give you the 5 here. Okay, and that's exactly what we got. Now 5 combination 2, I believe is 10. Let me check it on the calculator. Yes, it's 10. All right, so we have 10 there, and then 8, 2 to the power 3. That is what, 8, right? So we have 8k cubed, and then this part will be positive s squared over k squared. All right, now check this thing out. This k squared will cancel 2 of this k. It means that your answer is 80k x squared. Now the question says that the coefficient of the s squared term is 160. So that basically means that your 80k is equal to 160. So k is 160 divided by 80, giving you 2. All right, so you are done. Now let's look at the b part. It says find in ascending powers of x the first 3 terms of this expansion. Only the first 3 terms. So, and then simplify the coefficient of each term. Fine. So we have 1 plus 3x to the power 6. So we have 1 to the power 6. Then we have 6 combination 1, 1 to the power 5, 3x. Then we have 6 combination 2. Next thing we do is 1 to the power 4, and then we have 3x squared. They said the first 3 terms, so don't go beyond it. 1, 2, 3. 3 terms, okay? So we simplify. This is 1. 6 combination 1 is 6. So that should be 18x. Or let me check again. 6 combination 1. Definitely 6. Okay. Then finally, we have 6 combination 2. 6 combination 2, which is 15. Right? So you have 15. But this is 9, right? Because it's 3 squared. So 15 times 9 will give us 135. So you have 135x squared. All right? So you leave it like this for your 2 marks. And then this is the most interesting part of the question. They're saying that when that is written as ascending powers of x, the first 3 terms are there. Okay, So you should find a and b, no problem. So just write 1 plus 3x to the power 6, all right, a plus x squared. Now go back, look at this thing very well, okay? It is exactly what you expanded here, and these are the first three terms, and the question is really about the first three terms. So the first three terms for this is actually 1 plus, I think 18x, yeah, 18x plus 135x squared. Let's see, it's 135, yeah. All right, so we are multiplying that by this quadratic, which we can expand to give us a squared plus 2ax plus x squared. All right, so we can further expand this. I'll use the 1 to expand first. So I'm going to get ax plus 2ax plus x squared. Then I'll use the 18x to expand. So I have 18, can I just write 18a square x? All right, and then I'll have 18 times 2, I believe that is 36, right? Yeah, 36 a x squared. Be careful because this x multiplies this x to give us the x squared, then plus 18x cube, okay? All right, so the next thing that you want to do is use the 135 to expand. So I have 135 a squared x squared. Then you have 135 times 2 is giving you 270. So you have 270 a s cube, and then you have 135 x to the fourth power. Now if you look at the answers they gave us, is having only s squared, so you are interested in rearranging up to the s squared. The rest are just nonsense, you don't need it. So first we have our constants. We have a squared. Apart from a squared, what other constant do we have? What other constants do we have? We don't have any other constant again. So a squared is done, and then we have plus. Now let's arrange the x values. So we have 1, 2, the only 2. So that means we have let's see, 2a plus 18a squared. Then I factor the x out. Now let's deal with the last one. That's the x squared terms. 1, 2. Do we have any x squared term again? 3. What else? That's it. Okay, so that means that we can write 1 plus 36a plus 135a squared x squared. All right, so remember that the question said what we have done here is equivalent to this. Okay, so we can just compare it and then work with it. All right, so we have this. So we can say that our constant a squared is 4. That makes a plus or minus 2. But you hold on, we will determine what a really is later on. Then if you compare the coefficient of the x, all right, the x here, you can see that all that you have in this bracket is equal to 68. So we have 2a plus 18a squared is equal to 68. So this is a classic quadratic that I believe we can work with, all right? But unfortunately, I'm just going to put it on the calculator and then get my answer, since the question is not about quadratics. Okay, so I have 18, I have 2, I have negative 68. I'm getting answers such as negative, that is, a is giving me 1.89, and then I have a again giving me negative 2. All right, so right now, if you consider, we have different a values. Okay, so the first one we got plus or minus 2, and now we are having this. So what a do you settle on? Well, you settle on the a, the value of a that is common in both equations. -2 is common in both equations, so therefore you can say that a is equal to -2. Okay, now we are about to look for b. Well, compare the coefficient of the s squared terms, right? So that means that we have 1 plus 36a plus 135a squared is equal to b. But what is the a that we settled on? Well, we settled on -2. So just put -2 there. You have 36 into bracket -2. You have 135 into bracket -2 square. Everything should give us b. And then you just grab your calculator and then you do the right thing. So you have 1 plus 36 into -2 plus 135 into -2 square. And that is giving us b value of 1469. Okay, 469 like this. And then we are done. The next thing that we need to look at is also this also very much 21. Let's look at this paper. Is May June paper 1-1 is 8 solid marks. Oh my gosh. So for this one we need to be really careful. Let's read the question, analyze it, and then solve it. All right, it says the first 3 terms of the expansion this in the ascending powers of x can be written in this form. So you should find a, b, and c, and those a, b, and c are what? Integers. Okay, so this question has some similarities with this one that we just solved. Okay, and we are going to apply the same concept to solve the question. All right, so let's see. It says that the first 3 terms of this expansion, so I would say that you just take the first one, a plus x to the power 3, and expand up and get the first 3 terms. That's all you need. Okay, so that will give you a to the power 3, and you have 3 combination 1, a to the power 2, x. Okay, and now the next thing is 3 to combination 2, a to the power 1, and then you have x squared. Okay, these are the first 3 terms. So just simplify it. That will give you you have your a cubed, 3 combination 1 is 3, so you have 3a squared x, then 3 combination 2 is also 3, then you have a x squared. Okay, so this is your your first 3 terms of the first one. Now let's look for our first 3 terms of 1 minus x over 3 to the 5th power. So that's 1 to the power 5. Then you have 5 combination 1 to the power 4. You have negative x over 3, 1. Okay, and then we have 5 combination 2, 1 to the power 3, negative x over 3 square. Okay, now this will give us 1, 5, and then the next one is this. So we can simplify this and write negative 5 over 3x, right? Sure. So negative 5 over 3x. All right, then the next one will become 5 combination 2 is 10. So we have 10 here, and then we have over 9, and we have x squared. Okay, because if you get this as 10, this is 1, this is x squared over 9. So I mean, it simplifies to this. So these are the 3 terms here. So really, if we say that we are expanding a plus x cube and then 1 minus x over 3 to the 5th power, what we are saying is that the first term, this, all right, okay, just add this to it to show that it continues, just that you are ending at this place. Okay, times the second, where we got 1 minus 5 over 3x plus 10 over 9x squared. All right, if we are to expand this, just pay attention to what they gave us. The highest s square, the highest degree of x is square. Okay, 2. So we are not going to go to the cubics, we will end at the quadratics. So I'm first going to use the a cube to multiply through. So I have this minus 5a cube over 3x. Then I have plus 10a cube over 9x squared. Then I have 3a square x. Then I have minus 15a square over 3 x square, yeah. Then finally I have minus 30 over 9a square s cube. Right, then I have 3ax square minus 15a s cube over 3, then finally plus 30a x to the 4th power over 9. Like I said, we are not interested in the x that is more than a power of 2. All right, so now let's simplify. So we have our a to the 3rd power. Let's look for the x terms. The constant, I believe the constant is only one, this one. We don't have any other constant again. Okay, so for the x term, we have this, and that is, yeah, pretty much that's it. So that means we have plus negative 5a cube over 3 plus 3a square x plus. Now let's go and take the s squares. So we have this guy here. But let me use a different marker before I get confused. We have this guy here. We have this one. And that one. I think that's it. So we get our 10a cube over 9, and then we have plus negative 15 over 3 is 5a. Sorry, that's negative. So we have negative 5a square. Then finally we have plus 3a. The square goes out. Cool. Now we are going to compare it with the 27. This one, 27 bx c squared, right? So this is equivalent to 27 plus bx plus cx squared. Okay, so that means that the constant matches with this 27. So your a cube is equal to 27. You take the cubic root of 27, that is 3. All right. Now, if a is 3, then we can easily find b, because this also matches with that, comparing coefficients. So negative 5 over 3a, but we know a is 3, so this cube plus 3 square is equal to b. So b will be equal to, just put the whole thing on the calculator, okay? So negative 5 over 3 into brackets 3 cube, which is about 27, all right, plus 3 into bracket 3 square, which is also 27, and that should give you negative 18. Okay, so now let's go and deal with c. C is 10a cube over 9 minus 5a squared plus 3a is equal to c. So you have 10 into bracket 3 cube over 9 minus 5, and then we have 3 squared plus 3 into 3. Just dump the whole thing on the calculator. You are going to have 10 into bracket 3 cube over 9 minus 5 into bracket 3 square plus 3 into bracket 3, and that is going to give us negative 6. So these are our values of A, B, and C for the entire 8 marks. Right, so I believe this question is a lot I mean, you have to take time, especially with expansion. Make sure that you don't omit anything or make any mistake, okay? But taking the expansion aside, I believe that you'll be fine. You'll be very, very fine. All right. Let's look at the next question. It says that expand this and simplify each coefficient. Okay, this seems like something we can do comfortably, right? 2 to the power 5, 5 combination 1, 2 to the power 4, negative x, 5 combination 2, 2 to the power 3, negative x square, 2 to the power 3, 5 combination 3, 2 to the power 2, negative x cube, plus 5 combination 4, 2, and then we have negative this power 4, finally plus 5 combination 5, 2 to the power 0, negative x to the power 5. All right, so let's simplify everything. 2 to the power 5, I believe that is 32, and then we have 5 combination 1. We are going to multiply that by 2 to the power 4, which is 16, and that should give us 80. But that will become negative 80x because the x is negative. Well, the next thing will be 5 combination 2, which is 10. So we have 10 times 2 to the power 3, which is 8, and that will give us 80 again. But this is 80x squared. Then 5 combination 3 is also 10. We are going to multiply that by 4, and that will be 40. However, be careful. This x is negative and it's a cube. That means that the answer is still negative. So I have negative 40x cubed. Then you have 5 combination 4, which is 5. 5 times 2 is 10. And then you have 10x to the 4th power. Then finally, 5 combination 5 is 1. 1 times negative x to the power 5 is just negative x to the power 5. So yes, that is the end of the story. We've expanded it, we've simplified it. Then they are telling us that, and hence solve this guy. At a glance, you say, oh my God, this looks nasty. Yeah, it looks nasty, but it is not nasty, you know. It's kind of manageable. Why am I saying that? Well, for one thing, look at this guy that we just expanded. It is the same guy coming up here. So, when you see enhance solve, it means that whatever you did in the part A has something to do with the part B that you are about to work on. All right, so we are not in the dark. Now, what can we do? Well, for one thing, I can't tell you exactly what we are going to do, but what I can tell you is that let's try solving it. Okay. Now, you know, in indices, if you have this 2 minus x to the 5th power times e to the power 80x over this plus 32 is equal to this. You know that what can be done is to probably, add these two, their powers. So what do you get? You get 2 to the power e to the power 2x this plus 80x. All right, you let me deal with the numerator first, okay? I don't want to do a lot of things. So the numerator, I'm dealing with that first. Remember, we've expanded it and we got what we got here. Okay, now, so that means that we have e to the power. Let me use this color as, so we have 32 minus 80x plus 80x squared minus 40 s cubed plus 10 to the power this minus 5, that, right? And now we said plus 80. Let me write that in blue. So we can see that this and that will get rid of themselves. Okay, so that means that our numerator is now 32 plus 80x squared minus 40x cubed plus 10x to the fourth power minus this. Okay, well, this thing that we have is being divided by the denominator, okay, which is this. What do we know about division? Indices says subtract the powers, so that means that we have e, then this power. All right, we write that beautifully. Is going to, all right, we will subtract on the value on our right hand side. And now open your eyes here. This and that will get rid of themselves, and the 32 here will get rid of the 32 there. So we have this goes with this goes with that. That means we are left with this. Okay, now the question also says equate it to this guy. Okay, so we are going to equate this to this friend of ours here. Okay, now one thing we can do is to divide both sides by this. That means that, listen, you have your e to the power 80x squared minus 40s cubed minus x this. However, it has to subtract because it's dividing, so you have minus this is equal to 1 because e to the power negative 5 over that is 1. Now this is what we have, right? The next thing you want to do is to, get rid of it, because this, let me use different highlighter, this and that will get rid of themselves. So you are left with e to the power 80x squared minus 40s cubed is equal to 1. You can even take the lane of both sides. So we have lane e, this is equal to lane 1. And lane 1 is actually 0. You can confirm that on the calculator. So that means, okay, let's do this. I think we need space here to work the remaining part. So this thing, we can just squeeze it and drag it here. All right, and then continue the workout. Okay, so we have that will just become 80x squared minus 40x cubed is equal to 0. Right, so we can factor out 40x squared. So you are left with 2 minus x equals 0. That means that x is equal to 0 or x is equal to 2. All right, so these are your 2x values. What do they want? They said we should just solve it. Okay, so we are here. These are the 2x values that we got. This question is quite interesting. It would take you some practice to perfect it, but I believe you were able to follow through my presentation. So all that you have to do is to apply your laws of indices, and then later on you apply your logarithmic knowledge to solve for the values of x. All right. Now this question says that the first 3 terms of the expansion, this is and this, you should simplify each. Well, I believe this is something you can do. We've done this over and over again. Okay, so due to the B part, I'm going to do this particular question. I wouldn't have done it. I would have just skipped it to look for new questions. But the B part is interesting, so we got to do it anyways. Which year is this? 2020. Okay. Right. Well, before we do this question, let me see if there's another question that is worthy of our calculation. Yes, this question 9, we will look at it, and then probably okay, we've solved a question like this, so I will let it go, and then probably look at this question 8, and then we'll call it a day. Okay, the rest, I mean, just I've put the worksheet in the description, just solve it. All right. Okay, so let's solve this one quickly. It says the first 3 terms, we have 4 minus x over 16 to the power 6 is equal to 4 to the power 6 plus 6 combination 1. We have 4 to the 5th power negative x over 16. Then we have 6 combination 2. We have 4 to the 4th power, and then we have this 16 squared. These are the first 3 terms, so we end here, and then we simplify. 4 to the power 6 is a huge number, 4096, and then that one will become 6 combination 1 times 4 to the power 5. That gives us, these values are huge, my friends. For 1 this okay, times negative x over 16. Then we have 6 combination 2 times 4 to the power 4. That will give us 3840, okay, times x squared over 16 squared is 256. So we simplify to get this will become negative, obviously. 6144 divided by 16, that is 384x. Then this will become 3840 divided by 256. That will give us 15x squared. Cool. For your 3 marks. Hence, that means that what we did here is useful there. Hence, we should expand this. Well, but we are looking for the term independent of what? X, right? Okay. So we have already expanded this one, and then we got this. So we can write this minus that over 16 to the 6th power times 1 minus x over 1 over x squared. Now, the first one is what we just expanded. We got 4096, 384x plus 15x squared. And then this guy is what we're about to expand. But we can expand that guy easily and then know what we are dealing with, okay? If it's a quadratic, I don't use the binomial expansion. I can just expand it. So you have your x squared, and then you have minus. This times that is 1 times 2 is 2. And then you have plus 1 over x squared. Okay. So we want to find the term independent of x. That means we are looking for the constant. Now, before you even attempt, you can just don't expand everything. You can use shortcut here, okay, to get a constant term. This times that is a constant, right? Cool. And then this times that will also give you the constant because the s squares will cancel out. So that's all you need, okay? So your 4096 times negative 2 is going to give you negative 8192. Then you have plus 15. So your answer is plus 15 is negative 8177. And then you are done. Okay, but if you want to fully expand everything and then just add the constants, that's also fine. Just that it will take much time that you don't have. Okay.